Hello, I've had a question in Unit 3, Lesson 4 about one-sided limits, and I'm looking at question number 6. So earlier questions in this particular set of homework, they gave you graphs to work with. Now, in this case, you have to create your own graph. So I'm going to talk about creating a piecewise function so that you can answer questions A, B, and C. So basically, we treat this as two different functions. So there's your first one, there's your second one, and both of them together combine to create g of x. So what I always tell people to do for the first little bit until you get comfortable is you go equation 1, y equals 1, x squared, and my second equation will be 2 minus x. Now, I'm going to create a table of values because there's only certain values that are eligible here. So for the first one, my x values have to be less than or equal to 1. So I can start at 1, and I have to go down. So 1, 0, negative 1, negative 2, and so on and so forth. Plugging it into y equals x squared, I get 1, 0, 1, and 4. So I'm going to go ahead and I'm going to plot that, keeping in mind it was less than or equal to, so that'll be a solid dot. So 1, 1 is a solid dot, 0, 0, negative 1, 1, negative 2, 4. So my graph on that side, that's what it looks like. Now doing the same thing, x, y. This one, my x values have to be 1 or greater. I'm going to put a star here because that 1 has to be an open dot because it's greater than, not equal to. So putting those points in, plugging them into the equation, 0, negative 1, negative 2. Plotting my points, I'll change colors. Because of this, this will be an open dot because of, it's just less than. So I do an open dot at 1, 1. Now we see that there's overlap. So that means that really the graph's going to be continuous because both points are shared with both piecewise functions. So 2, 0, 3, negative 1, 4, negative 2. All right, so this is what the function g of x looks like. All right, now we can do our one-sided limit analysis. So now I'm going to answer question A. So it's asking me if we approach from the negative side of 1. So I'm going to take my pen, and I'm just going to, in my head, I'm going to say, okay, there's 1. That's the location. This is the negative side. This is the positive side. So I'm going to slide down the graph on the negative side. So here's the negative side. So I'm sliding down the graph because I want to see what's the value. And it looks like it's going to be a 1. So that means that it appears, one-sided analysis, that as we approach it, it looks like it's going to equal negative 1. Now, the next question says do the same thing, but go from the other direction, the positive side. So the positive side's over here, so I'm going to come up the graph. So here I am sliding up the graph. At 1, looks like it's also 1. So that means that left side is equal to right side. I'm kind of jamming this in here, sorry about that. So 1 from the, oops, I'm going to jam it in. I guess I'll make it look right. So the limit as x approaches 1 from the negative side is going to equal the limit as x approaches 1 from the positive side. Because those are equal, that means there is a limit or a value, and it will be 1. All right, so hopefully that helps you get along or get started. If you have any further questions, please let me know, and I'll try to clear them up.